Hello, my name is Ben. This is a video of the use of this chemostat simulator in the studying of bacterial chemotaxis. A chemostat is a model of the intestine. Normally the intestine, of course, is in the gut of the person. A chemostat is used in a microbiology lab to simulate the gut and to study bacteria in it. Chemotaxis is the mobility of bacteria to the intestinal wall. The bacteria are attracted to chemicals given off by the wall. Before you watch this, it probably would be a good idea to read the introduction to the simulation and the simulator software. Before we go over the function of the controls, let's just see what the end result's going to be, just so you have a better idea. Just load. Now you see what the simulation is. This is simulating the chemostat, and these are the walls of it to the left and right. And then you have that's the x-axis, and then you have the up and down the y-axis here. The z-axis goes in and out of the screen. So that's the ultimate result. Each of these dots is a dot representing a bacteria. Now let's look at some of the functions of the chemostat simulator. On the left is the load. You just press it to set all the bacteria equally throughout the chemostat. So you have to do it each time you're going to run the simulator. And then here we have front, which is the looking at it through the front, the XY. Then we have the top, looking at it through the top, and then the side, which is similar to the front, is used here. This is the location of a single bacteria. Here we're looking at from bacteria number 1 to 100. This can be up to 1 to 5,000. Then on the left here, we have the percent of the bacteria which are chemotactic. That means that the bacteria, 100% of them, all the way down to none of them, are chemotactic. Either that or they just swim about naturally without any chemotactic attraction to the side of the intestine. We have Y, which is downflow, which is when we had the chemostat in front of us. That's the flow of the fluid through the chemostat simulator. Immunity affects the ability of the chemostat simulator to kill the bacteria, basically. And people supposedly have immunity to bacteria in their gut. And then we have chemostat parameter, which means that the chemostat simulator or the intestine of the host gives off the chemicals which are needed for chemotaxis of the bacteria. Then finally we have duration of simulation, which can be 1 through 4, and that affects the duration of the simulation. So we press load, and then if we're going to go with the front view of it, we click it here, and there you see the bacteria all chemotactic, but some of them are red. Those are the ones that are killed because we had immunity checked off. And then to close it, you just click up here. Okay, let's look now at a couple simulations. Here we have 100% as the percent of bacteria that are chemotactic. That means all the bacteria are chemotactic. Y downflow is the flow of the fluid in the chemostat. And if we had it greater than 0, there would be a flow of the fluid that would push the bacteria down to the bottom of the chemostat. Immunity is the ability of the host to kill some of the bacteria. Then we have chemotaxic parameter, which there was no parameter when parameter goes up, let's see, to 1.5, that means there's chemical which is emitted from the chemostat wall, which the bacteria will swim towards. So first we load the initial values, which puts the bacteria evenly throughout the chemostat. And now, oh yeah, in here we have bacteria, 100 bacteria from bacteria 1 to 100. This could be up to 1 to 5,000. Okay, so now let's look at it. And you can see there's Chemotaxis in this simulation, and the bacteria swam towards the wall and are found there now. Now let's make it so that there's no chemicals coming out for chemotaxis. Actually, we're going to leave it for chemotaxis. And we're going to make it so the bacteria are not chemotactic. So we'll go down to 0 here. So let's load it. Arrays are loaded. And now we go look through the front. And there you see they're non-chemotactic, so they're blue. And they also are not going to the edges of the chemostat. So that's another simulation. Very interesting. You can make it 50% chemotactic, in which case 50% will be blue and 50% green, and only some of them will be chemotactic. So actually, let's go up to 50%. Then load. And you can do this in several different ways. Let's go front. And there you see blue and green ones, and half of them only are chemotactic, and you see not as many are pulled towards the wall of the chemostat. To close it, and you shouldn't close it or try to close it while it's running. Okay, let's try one more simulation. We're going to make the chemicals to 1.0, so it's not chemotactic. And we'll make all the bacteria chemotactic, but you see they're not going to be showing chemotaxis because this is 1.0. But the interesting thing is, if you look here at the downflow, we'll make the downflow 1, and you'll see what happens if there's no chemotaxis, but there's flow through the chemostat or the gut simulation. We load it, and then we look through the front. And as you can see, they're going down with no chemotaxis. So as you can see, with different simulations, with different settings, you can look at the bacteria and see how they act in the simulation. There's one thing I didn't show you. It is in your simulation guide. Load and reset parameters. You can get it so that your bacteria initially will be within these range from left to right. It's through 5 to 95, and you have here 5 to 95, and then Y and Z. So you can change this if you want. And that is about it. I just showed you a couple, 2, 3 things. However, you can try it in many different ways, and you can look at the programming techniques I used in the introduction that you can download with this app. Thank you very much. I'm glad you listened. Bye-bye.